This next equation is a little bit longer. 24 divided by 3 minus the square root of 3 squared minus 2 plus 3 equals 3x. Now, that might look a lot different than this, but it's the same. And it's in the sense that it's an equation. We have on one side of the equation a variable here, and the other side of the equation just an integer that represents that variable. Okay, so do a quick order of operations. What does this mean? This means the order in which we do each of these operations. So the first thing we want to do is parentheses. Do we see any parentheses?
Yes.
All right. So the first thing here is 2 plus 3. So that's what we're going to do first. So that will be 5. The next thing, exponents. What is an exponent? Does anyone know what an exponent is?
Something to squared or...
Okay. So it's basically, we have the number here, we call this the base, and then the little thing up here is the exponent. Okay? And this just tells us how many times we multiply the base by itself. Okay? Without getting into all the variations, you can have 3 to 0 and that equals 1, blah, blah, blah. I'm not going to get all these things, but just understand that an exponent, E-X-P-O-N-E-N-T. So we have 3 squared. The exponent in this case is the 2. And again, that just tells you how many times to multiply the base by itself. So in this case, 3 squared equals 3 times 3, which just equals 9. So here we have 3 squared 2, so that would be the next thing we want to do. And that would be 9. Small explanation of square root is basically kind of think of the opposite of, in this case we said this is to the second power, or squaring. Square root is kind of like the opposite of that. So if we take a number like 4, that equals 2, meaning what number times itself gives us this number within, I believe it's called the radicand. What number within the square root symbol times itself equals 4, in this case 2. If we took this one here, 3 squared, in other words, 9 square rooted, what number times itself equals 9? It's 3. Okay? So we're going to square root this whole thing within the square root symbol. In this case, it's 9 minus 5, which is 4. And the square root of 4, as we pointed out, what number times itself equals 4?
2.
So that whole thing there just equals 2. So now we're going to do something which is very common in algebra. We're going to rewrite the equation because it just can get kind of messy. I'm not saying you can generally do this kind of thing in your head, but it just gets messy, and it's really good every so often just to rewrite it to see where you're at. All right, so I rewrote the equation. 24 divided by 3 minus 2 equals 3x. Now what's the next thing? Multiplication. Is there any multiplication here? Very good. There is multiplication. But since we're looking to solve x and we don't know what x is, we can't really do that one yet. So the next one is D, division. And that's where we see 24 divided by 3, of course. And 24 divided by 3 is?
8.
8 minus 2. Again, I rewrote the equation. You don't have to do that. But 8 minus 2 equals 3x. Okay? That's the next step in the order of operations. The next one is addition. Is there an addition, any addition there? No, so that's gone, and the last one is subtraction. 8 minus 2 equals 3x. I'm going to rewrite it here. 8 minus 2 equals 3x. We have the subtraction there. 6 equals 3x. Now look at that. We're nearly right here. It's funny. Look what we started with. You know, chaos. And we're almost here. 6 equals 3x. So what number times 3 is 6? That's what we came up with. It's as simple as that. All right. So now what we're going to do is the opposite, because remember before we want to isolate the variable, and we've nearly isolated it completely. We're going to do the opposite. We're going to divide by 3. And remember what we always do to one side?
We do to the other.
Very good. We do to the other. So these cancel out. Remember, that's just, when I cross those out, it means 1x, because 3 divided by 3 is 1. What's that number called? Anyone remember?
Coefficient.
There you go. Very good, Dave. Coefficient. So we don't need to write the coefficient 1 in front of a variable. It's unnecessary. Okay? It's unnecessary. There's a concept in science called Occam's
razor.
Occam's razor, which is beloved by anyone who's ever done anything involving anything. But it's a great, it doesn't mean writing or music or math or anything. It's just, what is it, Dave? What's Occam's razor?
Total efficiency.
Okay? You don't want to have any unessentials, okay? Occam's razor, just really get to the point. 6 divided by 3 equals 3x. We're going to divide by 3. So reason why we don't put 1x, that's why I brought up Occam's razors, because it's like if you know that any variable, be it y, z, the happy face, John, Rita, whatever, it just means it times 1. Why would we write 1? It's kind of, it's utterly pointless. Okay? Not utterly pointless. Actually, there are times when it would help you to do that, but in this case, it's not one of them. And in general, you don't need to do that. So we're divide by 3, divide by 3. 6 divided by 3 is 2 equals x. Ta-da, voila, there we go. So x is 2. Now what do we do? Are we done? I mean, yes, we're done in a sense, but what would be a good idea to do?
Probably rewrite the equation.
Throw 2 into the...
There you go. Throw 2 in. I like the way you say it. Throw it in there. Throw it right in there. Put that 2 in for the x. Okay? So 3 times 2. We'll just do this side of the equation first. 3x is
6.
6. So I'm just going to write that here. All of this has to equal 6. If it doesn't, then we've made a mistake. So let's just a quick review of order of operations is the first thing we want to do.
Parentheses.
So why don't you guys do it? What's the parentheses?
2 plus 3, yeah.
So 5. And then we have exponents.
Okay. 3 to the 2, which is 9.
9 minus 5.
4.
4. And then we're rooting that.
Square root of 4 is 2.
So we're just going to write that here. Then we're going to go to the next one, multiplication. We don't have multiplication. Division, 24 divided by 3.
8.
Minus 2.
6.
And that's what we had here. So we just checked it, that's all. And you say, well, we already did all of that right here. That's why you want to show your work, because you can also just kind of eyeball it. You don't actually have to do the whole thing again. But it does help to do it again. And it's fun. It wastes a lot of paper.